Cool. All right. So, yeah, morning, everyone. So, last week we had a look at a bit of an introduction to C++ for those who aren't here. There's just a couple more things I want to cover on that before we move into Open Framework. So if you missed the lectures, look online. We don't have time to go over them again, unfortunately. So yeah, we looked at some basics of C programming, and there's just a couple of advanced stuff, a couple of advanced things I want to touch on. Again, because you're fairly likely to run into these doing open frameworks. And the main things I just wanted to talk about are pointers and memory management. Where are we? All right. So what a pointer is literally a pointer to a place in memory where a value is stored. So I might just fire up Visual Studio so we can see some examples of this in action. Did I just get... somebody shut that door. Thanks. Alrighty, file new. C++, what am I doing? Add new item. Right, so we've seen before in processing and stuff things like int x equals 6, int y equals 4. You know, that's fairly normal. Basically what this is doing is it's creating, includes range. It's creating a little piece of memory, putting the number 6 in it, and then saying, okay, x points, or like name this chunk of memory x, creating a little chunk of memory, putting 4 in it, and saying, okay, name that chunk of memory y. What you can do in C that you can't do in Java, however, is you can do something like this. Now what that's doing is, if we assume that this is our RAM on our computer, what we do is we say, okay, this chunk here will be, we'll put the value 6 in there, we're going to call that chunk x, and over here, you know, the computer will give us a piece of memory when we ask for it, and put 4 in there and say that's y. What this last line is doing, int star sign, star, wrong one, star x equals ampersand, star z equals ampersand x, sorry. What that star z means is that we look at what's before it, so int star z, and so what that tells us is it's going to be int star is a pointer to an integer. So somewhere in memory we're going to have an integer, and we're going to have this variable z which points to it. What this ampersand does is it basically asks us for the address of x. So x will be stored somewhere in our memory, and often it'll be some sort of big hexadecimal address like that. And basically when we say int star z, we create a new variable z which is of type pointer to integer, and when we say that equals ampersand for address of x, basically what we'll do is we'll set z to 0 times 0 c 0 0 a 7 f, or whatever the address of c is. So essentially, if x is this piece of memory, z points to where this piece of memory is. So let's just run this and see what we've got. So yeah, if this isn't familiar with you, look at the lectures from last week because we went over this then. Alright, so we print out our values of x and z, so 6 and 4, and if we have a look in our locals, we'll see x is 6, y is 4, and when we execute over this line here, int, or pointer to an int called z is the address of x, we see that z is now at equal to 0 by, or 0x0031 FD1C. So that's the actual place in a memory where x resides. And if we actually open this out, Visual Studio is smart enough to figure out, or follow that pointer and say, okay, let's go to this address in memory, and sure enough, that address in memory is 6, because that's what's is stored inside X. So yeah, we define a pointer by using the star symbol. So int star obviously means a pointer to integer, float star means pointer to float, so on and so forth. And we can get a pointer by referencing it using the ampersand operator. So ampersand will get us the address at that point. So this is similar, pretty much same example we had. Actually, I'll follow the example on the text there. So int, and then y equals x, and int z. Sorry. So I think that's pretty much what we've got there. Yep. So yeah, in this example, we create a piece of memory, put the value 6 in it and store it as x. Then in this one we say, okay, point y to the address of x, so x is 6, y points to 6, and then when we have a pointer and we put a star behind it again, the terminology is a little bit confusing because this is how we create a pointer, but this actually gets us the value which is stored in the address pointed to by the pointer. So what we end up with in this case, so x equals 6, y is a pointer to the address of 6, or to the address of x, sorry, and z equals the value in y, is if we look at our memory, basically we end up with this situation here where we have x is some pointer or some piece of memory with the value 6 in it, y points to the address of x, and then we create, when we go int z equals the value which is stored in the memory address pointed to by y, or dereferenced by y, we basically create a new value and copy that into it. So yeah, why would we ever want to do that? Well, it allows us an easy way to pass data around for one thing. So let's start with this example here. So if we go set x to 6, and then so set x, create a variable called x, set its value to 6, then print its value, and then call this add1 function where we add 1 to that value. And then print its value out. Sorry, try and do this as I go. So now, right, so we have our variable called x, and we're storing it the value of 6. We print out its value before, and it's 6. Then we call this add1 method. So add1 adds 1 to the value of x, so x is 6, now x is 7. We print that out during 7, and then when we print this out again, what is it going to say? Anyone want to take a guess at what this last after will have after it? So it's actually 6. So what's happened here is this x here and this x here are actually different x's. So I could make this a little bit less confusing by doing this, perhaps. So even though they have the same name, they're actually, basically what we're doing is we create a value x to begin with, and we put in the value of 6, and then when we call add1, with int a, or whatever, what we actually do is we create a new space for something called a, and then we just copy the value in it when we we have this method here, add1x. Basically, we're not actually passing this x here. All we're saying is get the value out of that and pass this into this. And so basically what we end up with is something which looks like this at the end of it, int a equals 6. So we create a new value called a, put the value of 6 in there, then we add 1 to that, so this becomes 7. And then we print this one out, and then we jump back to the original one, and we print out the value of x, which is 6. So if we look at that on a sort of method timeline, we have our main method, and we say x equals 6, and then we print that out, and then we call add1 x, and that then comes over here to our add1 method. And so here we basically say x equals 6, then x equals x plus 1, and then we print that out. And then we return back to here. And even though we've changed this value of x over here, it's add1's copy of x. So it goes from 6 to 7. But when we return, this has remained unchanged. We haven't touched this piece of memory. We've just copied the value over and then changed it. So it'll be like me saying to you guys, okay, or it'd be like me providing you guys with a copy of a file. So you can modify your copy. Like if I email it to you, you guys can modify the copy of the file, but my copy of the file remains unchanged because it's just a copy of it. So how is that different when we have pointers? So let's change this now. So add1 now takes a pointer to an integer. I have to just change it up there as well. So the reason I have void add1 here and void add1 down here, C does not do forward. Can't remember the name, the proper name for it, but basically C's not smart enough to basically go forward looking for functions. So if we have a function we need to call, we need to tell it what its prototype looks like first. So we have to say that add1 is going to be a void method which takes a pointer to an integer, even though it's defined right here. When C reaches this line here, it says, well, I don't know what add1 is, I haven't seen it yet. Java, on the other hand, will do this forward searching. It'll actually find it. This is one of the sort of pet peeves about C and C++, and it's one of the things which is pretty, these days, pretty unique to C and C++, like C#, Visual Basic, Java, all these things all do forward lookups, but C doesn't. So if you get a complaint that it doesn't know what a function is, even though you can see the function there, just have a look. If you're trying to call it before you declare the function, you need to put what's known as a function prototype at the top, which is the same as the function. It's just you just put a semicolon at the end rather than the function or method body.
Does it work if you just put the whole function on top?
Yep.
And then just miss it?
Yeah. Well, I mean, there will come times where you can't put everything before everything else. Yeah. So if I say had another function, or if add one function, like you have two functions which call each other, you can't sort of end up putting the two.
Going up its
Yeah, exactly. So yeah, I mean, I could definitely cut and paste this whole function, put it before main, and then it would work, and I wouldn't need this. Yep, good question. Right. So yeah, we've changed this add1 function now, so it takes a pointer to an integer rather than just an integer value. So now I need to get the address of that. And what I can do here is I can say, okay, add1 to the value of a. And now if I've done this correctly, so if we go, put that over there. So before is 6, and then we call add1. So we add 1 to the value of it during, printing out the pointer value, or the pointer address rather than the value in it. Where's my window gone? So before is 6, during is 7, and now when we exit back out, after is 7 as well. So in this case, what I've actually done, what am I doing? If we go back to this other example now, because I don't know that actually made anything easier to understand. If we have our chunk of memory, and we create our value x, and we put in at 6, in our main method. Now when we call add1, if x is equal to some value in memory, we're actually calling add1 with this value, 0, 0, 0, CE 0, 0, 1, 6, or whatever. And so we're actually saying, it's like me giving you a physical copy of the file, or it's like if I put my file on a network share and I'm telling you guys where you can access it. So rather than actually copying the value, I'm telling you where you can access it. And that way, when add1 makes a modification, it's not making a copy of the memory and then modifying that copy. It's actually modifying this memory address here. So in this, it will change that to 7, print that out. And then when we return to main, that piece of memory has still been modified. So the difference between doing things, so you have what's known as passing by value. So passing by value means you just make a copy of that value and give it to the method. Passing by reference means you pass a pointer to the memory address so that any modifications you do will be on that memory address rather than on a copy of it. So does everyone sort of get how that works? Sort of, hopefully. So the reason I wanted to bring this up is because last week we looked at this example here, where we have something like a class person, and a person has constructor, and a person has a destructor. I need to say those are public. And let's just say a person has so we have this class of person, and this person has a constructor and a destructor which don't do anything, but they also have a first name and a last name. So the example we looked at last week was person P, and then we could say P dot first name equals Adrian, P dot second or last name equals Clark, and that will compile and run just fine. Obviously doesn't do anything because I haven't in case you couldn't tell, C is my language of choice. Right, so yeah, where are we? So print out Adrian, Clark. So basically we're creating a class of persons, so exactly the same as we do in processing Java and everything else. We go P dot first name equals Adrian, P dot last name equals Clark, and standard C out, blah, 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 blah. However, what is very common to see in languages like C is something like this. So we don't actually create an instance of person P, we create a pointer to it, and then we'd have something. Now this is, again, a change in terminology, which is, structure or ways of symbols rather, which gets a little bit confusing. But if we're dealing with a pointer and we want to access members of a pointer, what we do is we use this symbol, which is a minus and a greater than mark, to access its members. So here we have person P, and P has two members, a first name and last name, so we go P dot first name, P dot last name. If it's a pointer to a person, we have to do P, and then this arrow first name equals P1 dot last name, like that. However, if I now try and run this, it should compile fine, but when I run it, it's going to complain that P1 is being used without being initialized. So when I create, using this example again, when I create P1, when I create P, which was the one which with, do it in here, person P, C is basically says, oh, we're creating a new instance of person, let's create some memory and make it large enough to fit this person's data in here, so it's going to have a first name and a last name and etc., etc. When I say person star, so pointer to a person P1, basically all that does is it goes, oh, okay, we actually just want a pointer, so I'm not going to bother allocating any memory. This person's using pointers, they must be smart enough to know what they're doing, so they can figure out the memory themselves. And it will basically point this to either nothing, so it'll just point it to nothingness in the memory, or it might point it to, like, it might just be uninitialized, in which case it might just be pointing to some arbitrary place in memory which hasn't been set up to store a person in it, so even if we do try and access it, we're going to get garbage out of it. So in this case, because we're running in debug mode, it's smart enough to know that, hey, you're actually trying to access this variable P1, you haven't actually initialized any memory for it, P1 isn't, there's nothing there, you've just got a pointer out into the abyss, basically. So it's going to complain about that. If I tried to run this in release mode, which is doesn't have all the debugging stuff in it, it will just crash. So a buffer overrun has occurred in test project, which has corrupted the program's internal state. So in this case, we're lucky enough that it corrupted the program and crashed it, but this is pretty much where you start hearing about all these exploits that people use to hack and stuff. It's because people have been doing stuff with pointers and they're not checking the memory and so on and so forth. So yeah, you have to be careful when using pointers, but unfortunately it's part of programming with C and C-based languages. Yes, we already looked at this, so modifying, like basically passing a thing by value, which is where you just pass in int x, float, whatever, or passing by reference, so we pass in a pointer and then we can modify the pointer. So yeah, when we tried to run this example here, which we've just seen, so person, first name, last name, age, create person P1, which allocates a piece of memory, create a pointer to person P2, and actually if we jump back to this code and we just move these down here so we can see what's going on. So we create P, and P gets all set up, and I don't know if there is a way to actually see where it's pointing to without explicitly grabbing a pointer to it. But you can see here, P has been set up. It has space for a first name, space for a last name. If we look at P1, its value is star CCCCCC, which obviously isn't a valid memory address. A valid memory address would have like a whole bunch more variation in it. So yeah, P's been set up, it's been created, some memory has been allocated for it. This one is just a pointer to nothing, to the abyss. And then when we try and set stuff to it, it's like you're trying to access memory or you're trying to access something which isn't actually pointing to anything. So what happens typically from here is we need to create a chunk of memory in the correct format. So we want a chunk of memory which will store a class of person. And the way we do that is actually quite similar to how we did it in Java. Oops. So we use this new keyword, and then we say what sort of class we want. So when we run this now, so P, actually, let's just run that again. So we see before we've initialized person P, we have two bad pointers. There's no memory, nothing's been done. As soon as we execute that line of code, it's been set up, we've got some space, we can start putting data in. P1 is all C's and all garbage, but as soon as we run this line of code, you'll see now we have a memory address, 00654D60. So C has set up a chunk of memory for us that we can now, or the operating system rather, allocate us a chunk of memory that we can now put some data in. And if we look first name and last name, we can stick information in, and that's fine. And now when I execute that code, it's basically P has Adrian Clark, P1 has Bob Kelpie, and we're good to go. So we've created this chunk of memory, which we can now work with. Now, the difference between Java and C is in Java, when you create a new person, it has what's known as a garbage collector. So it will see that you've allocated a chunk of memory, and as soon as nothing is pointing to that memory anymore, so as soon as you have no way of accessing that memory, it'll go, well, obviously you're not going to use this memory anymore, I'm going to delete it. C doesn't do that. So if let's see, if I go void create person down here, just get rid of some of this stuff. So if I call create person down here, in Java, because there is no way for me to access this person which has been created in here, Java processing, will say, okay, you have no way of figuring out what this memory is. You create a pointer, you create some memory, and then once this function exits, there's no way for you to access it anymore because the only reference you have to it is this person P1, and I can't access person P1 up here because it only belongs in here. Java processing, etc., will say, okay, you're not using that piece of memory anymore, I'm just going to delete it. C doesn't do that. So that piece of memory will remain there indefinitely unless I clean it up myself. And in fact, if I do something like this, which is going to just call the create person thing over and over again. Once again, we need to do forward referencing. So if I run this, and what's it called, test project. Here we go. So if you look at this number down here, which is the RAM which is being used, you can see that's gradually climbing higher and higher. So we're almost at a gig of memory used up now, because basically all that's happening is it's just allocating a ton of memory. Each time this function runs, it creates a new person. So it stores a little piece of memory, sticks some data into it, and then we lose the reference to that. So we can't actually access that anymore, which is a bit of a pain. But yeah, C's not smart enough to go, well, actually, you can't access that memory anymore, so I'm just going to delete it and return it to your program. And if I leave this running for long enough, I think once it hits like the 4 gig, actually, how much RAM does this computer have? Maybe 8 gigs. So once it hits that 8 gig mark, the computer's going to start chugging really badly, and eventually it's going to go, there's something incredibly wrong with this process, and kill it. If I'm lucky, it'll kill it. If I'm unlucky, my computer will just completely hang. So we're, edging up on 1.5 gigs of memory being used by my 10-line program now. So not ideal. So yeah, you need to free or delete any memory you create. So you can see here we have person P2 equals new person, and then when we're finished with it, we call delete P2. Or in this case, we have P1. So if we call the new method, remember that we have to call the delete method. And if I run this now, it's doing exactly the same amount of work. But if we look at this, it's sitting pretty steadily on 456 kilobytes of memory, so less than a meg, considering we're at 1.5 gig before. That's quite an improvement. But yeah, just things to know, because again, you're going to see this in open frameworks and any C code you write. So is everyone happy with pointers and memory management? Yep, hopefully. Worst case scenario, open up Task Manager and run your program. If you see your memory starting to escalate quite quickly like that, you've got a memory leak, which you need to fix. All right, so let's see. I think, I'm going to preface my talk about open frameworks. Maybe I'm not, because I don't have OpenCV installed on here. That's quite unusual. Okay, well let's just pretend that I have OpenCV installed on here for a minute. So let's say I want to make an OpenCV application. The first thing I would have to do is, so OpenCV is a computer vision library. So it provides a lot of computer vision functionality. So things for image processing, processing photos, processing videos from a web camera, doing all sorts of computer vision stuff. So all the AR demos you see here use computer vision processing and so on and so forth. So let's say I wanted to write a OpenCV application. So the first thing I'd have to do is go and download it. So OpenCV for Windows, and so on and so forth. And that will start downloading eventually, although it's from SourceForge, so it's going to take forever. But then once it's downloaded, it will, it's about 300 megs or something to download, so it's quite large to begin with. Once that's done, I then have to go and compile Visual Studio, so OpenCV, sorry. So I have to go in there, compile everything the way it's done, and then let's say we've got all that done, we're ready to go. So let me start my OpenCV application. So I'm just going to create a new folder on here and call it OpenCV and just pretend, because somebody's deleted off here. It was probably me, to be honest, but it's neither here nor there. So let's say OpenCV is installed, unzipped, compiled, whatever, in this folder. So let's say I want to create a new OpenCV application. So first open Visual Studio. Then I go File, New Project, because I want to create a new project. And we'll call it my OpenCV project. Okay. And then I need to create a new main file. So add item main.cpp. So now I have my main file. Cool. All right, so now let's start including some libraries. So I need to include OpenCV, actually OpenCV2, OpenCV. I'm going to try and remember what these are called. Core.hpp, CV2, hi GUI.hpp. So I've included these. Now I need to go in here and I need to say, okay, C++, we need to look in additional include directories, and that's going to be in desktop and OpenCV, and then there'd probably be a new folder under here called include. So I'd need to select that one, yeah, okay, and then I'd need to start typing up my code, and then I'd say, okay, well, it's not going to link, so I need to go into my linker, and first thing I have to do is add some additional library directories. So that's going to be in here. So select that one, and then I need to specify what the name of the folders I want to link is called. So 249d.lib, because this is the debug version, so then I don't have to go back and do everything I've just done all over again for the release version. So you can see before we've even written like any code really, we've had to go through all these friggin' hoops just to get where we want. So, and not to mention, if I then send you the application, you have to download OpenCV and you have to install it and compile it and blah, 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 blah. And if I then decide that I want to use something different from Visual Studio, I'm going to have to compile it for that one. If I'm going to use a different version of Visual Studio, I'm going to have to compile it for that one. So you can see, you know, it starts getting pretty tedious pretty quickly when you're dealing with these sort of libraries. And then if this is my first time using OpenCV, I'm going to have to learn how OpenCV works, like how all the pieces fit together. If I want to do something which OpenCV doesn't provide, I'm going to have to go out another library and figure out how to communicate between those two libraries. And it becomes a huge big nightmare of trying to get millions of different pieces working together. That's where Open Frameworks comes in. So Open Frameworks is an open source toolkit designed for creative coding, and it is a framework of libraries, and they're all pre-compiled for a thing. So you download Open Frameworks, you get OpenCV, you get stuff to handle video and images, you get stuff to handle audio input, you get stuff to handle Connect, you get all the stuff, and it's all written, it's all compiled, it's all ready to go. It comes with a project generator, so you click a couple of buttons and you start writing code. So it basically was designed to make the process of starting programming a lot easier, because, you know, I teach, help out with the computer vision course, the 4th year computer science computer vision course, and one of the thing I do is I teach, like, Richard Green, who's the head of computer vision. He teaches the theory, and I usually teach the practical side of things. And I come in very early in the course, and I give a 1 hour or 2 hour lecture on how to set up Visual Studio, how to set up OpenCV. 6 weeks later, I'm still getting questions from people who cannot figure out even step one. So this last year, I said stuff it, and I just told everyone they can use Open Frameworks, and basically focused on doing that instead. And after about a week and a half, everyone had it up and running. So, you know, it's for people who aren't programmers, because a lot of people who come do the computer vision course are from engineering. So, you know, they're more used to programming in lightweight environments, not using things like Visual Studio and stuff. So, you know, the thousands of steps you need to just get Visual Studio to do what you want to do, they're not familiar with, and that's why it takes so long. Open Frameworks is designed to help people program, because if you're making an app, what you want to be doing is programming, not messing around with Visual Studio settings trying to get it to do stuff. and it does that generally quite well. So yeah, it's an open source C++ toolkit for creative coding. It makes the setup process far easier than if you're just using Visual Studio or some other IDE on its own. They provide a whole bunch of add-on libraries which encapsulate a bunch of functionality the same way processing does. So, you're using processing and you want to do something, you go and you download a plugin or a library to do it. Without a focus, just focus at any point in time, it's pretty hard work to get it going. So say, we want to do something with open frameworks, and let's say I want to do something with the Kinect camera from Microsoft. So, okay, there's this one, there's this one, there's this one, Kinect Blob Finder, Kinect for Windows 2. So this is the new Kinect device. Say I want to use that, I can just download this. So I don't need to most likely don't need to download the Kinect for Windows SDK. I don't need to read all the information about that to try and figure out how I use it, because somebody's written a nice little wrapper around it, and everything will be the same as every other library in open frameworks. They all work the same way. You all call them the same way. It's all designed to be very easy to use. So yeah, it's a framework. It's a collection of libraries. So you still use. Actually, let's just jump back to this one. So if I say OpenCV, so OpenCV 2.2, 2.6.1, so on, OpenCV 2, so on and so forth. So all of these still use OpenCV, but somebody's done all the compiling, somebody's got it all set up so that you don't have to worry about doing any of that stuff. You just download one of these, unzip it to the right directory, and you can start writing your OpenCV code. So it's functionally no different from OpenCV, but somebody's done all the tricky, messy setup stuff so that you don't have to. It's written in C++, so depending on how you want to argue this, it is potentially more powerful than processing. Certainly written well, C code will generally be faster than stuff like processing in Java, because they're run through a virtual machine, essentially, whereas C is run directly on the processor. However, it's more complicated, as the examples we've been seeing. There's lots of little catches, which can make it more powerful, but it can also make it a lot easier to do things like crash your computer. Open Frameworks doesn't include its own IDE, so processing did. It came with that awful processing IDE, which is missing things like IntelliSense and autocomplete and all this sort of stuff. Open Frameworks doesn't include it, so you can use you have to use things like Visual Studio. Obviously, you can use something like Eclipse or NetBeans or whatever for processing if you want, but you don't have to. So, it's 6 of one, half and a dozen of the other. Open frameworks, you use better IDEs, but that's because you have to. Processing, you don't have to, but the default IDE is pretty bad. So yeah, you have to use an IDE for development. Obviously, that depends on what you're developing on. So if you're developing on Mac, you probably want to use Xcode. If you're developing on Windows, you can use Visual Studio. If you're developing on Linux or any platform, you can use CodeBlocks. And it runs on Mac, Windows, Linux, and there are also ways to get it running on iOS and Android as well. Yeah. So Open Frameworks is just like processing, sort of links and ties together various bits and pieces. So it can interface with various hardware. So obviously the Arduino we've been looking at, but we saw before it's got libraries for using the Kinect version 2, etc., etc., etc. Also handles a lot of media stuff. So C by default, in order to make it like a flexible language which will work on, so you can compile and run C on Windows, Mac, Linux, Android, iOS uses Objective-C, which is kind of like C++, but weirder. But yeah, so they're all supersets of the C language. But in order to make it flexible so that it'll run on all these things, C does not have any sort of media functionality by default. So it's got no way to open images, it's got no way to load videos, and so on and so forth. You have to use libraries to do that. And Open Frameworks provides all those libraries, so it basically makes media easy to use and communication, network protocols and stuff. Again, if you want to do network communication on Windows, you use Windows sockets. If you want to use it on Linux, you use BSD sockets. The way you create both these sockets are different and completely incompatible. It's just a nightmare trying to maintain the same sort of code base over multiple platforms, unless you use something like Open Frameworks, where somebody's done all the hard work and you get given a sockets library and it will decide, it'll check, am I running on Linux? Okay, use BSD sockets. Am I running on Windows? Okay, use WinSock. Like somebody's already written the library to do all that work for you. So you just say, create a socket and it will figure out what type it needs and do that for you. This is basically the structure of open frameworks. So if we start at this bottom level, we have the base libraries. So OpenGL, Glut, FreeImage, FreeType, OpenCV, the Connect SDK, all of these things will be sitting in here. So these are libraries you can download and use in C normally. Like there's no need to have open frameworks in order to use these. But each of these are written by different groups of people. Each of them works slightly differently. Each of these you will probably need to download all the documentation, read through it in order to make them work properly. What Open Frameworks provides is this middle layer. So in this middle layer you have something like OF graphics or OF image, and what that will do is that will use bits of FreeImage, it'll use bits of FreeType and QuickTime and stuff like that in order to basically say, do you want to load an image? Okay, I'll load an image for you. Instead of you going, okay, now what type of image is it? Is it a PNG image? Is it a JPEG image? Okay, I'll use FreeImage. Is it like something which QuickTime needs to read? Okay, we'll figure that. You know, Open Frameworks does that for you. It does all this stuff that, you know, normally you'd be spending ages going, okay, what libraries do I need? How do I call these libraries? You know, you just say, okay, OF image, load me an image, and it will do all the hard work, figure it all out for you and do it. And then and also this main.cpp is provided, so that does a lot of the initial setup and stuff that, you know, we don't want to do. So all we do is we basically write these two pieces of code here, testapp.h, which is our header file which we looked at last week, which basically just says the structure of our file. So here's all the methods, and testapp.cpp, which is where you write your source code. So 3 files, main, testapp, cpp, and testapp.h. But first, before we jump into that, I am going to have a little look at Open Frameworks. So Open Frameworks, obviously we've got add-ons, which we just looked at, which are libraries, which we will come back to later. Download documentation, so there's lots of documentation for various bits and pieces. I don't know why the internet's always so slow on this computer. So, you know, the core functions. If we want to do some 3D graphics, there's a bunch of functions to do that. Draw box, draw cone, draw cylinder, blah, 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 blah. Meshes, plane primitives, etc., etc. So some application stuff. So do I want to, or EGL is, so that's like OpenGL for mobile devices, in particular like iOS devices. So if we want to do iOS or Android, so if we want to do that, embedded GL stuff, we can do that. So setting up various bits and pieces, communication. Do I want to communicate with an Arduino? There's code to do that immediately. Do I want to communicate over serial? Various stuff for event handling, OpenGL, which is graphics. More graphics libraries if we don't want to use OpenGL. Some stuff for handling math, sound, etc., etc. So plenty of documentation there. Tutorials, a gallery, so there's existing people's source code on there we can pilfer like we did with the processing stuff. But let's have a look at the download. So unfortunately, there is a little bit of messing around required to begin with. So first we need to decide what we want to do. So do we want to build something for OS X, so Mac, for Linux, for Windows? Do you want to do stuff for iOS, so build stuff on iPhone? Do we want to do Android? Do we want to do stuff on the Linux ARM devices like Raspberry Pi or whatever? You know, you've got you covered. But let's start with Windows because all you guys are using Windows and I'm using Windows here. So, as I said before, Open Frameworks doesn't come with an IDE, so we need to pick an IDE. And for Windows, there are two ones which are supported by the team. There is Visual Studio and there is CodeBlocks. So Visual Studio Setup Guide, CodeBlocks Setup Guide. Now the problem with Open Frameworks, and this is a little bit of a nuisance, is that Open Frameworks, in order to support all these different libraries, they have to basically pick a version of whatever IDE you're using. So Visual Studio, they have to say, okay, we're going to support Visual Studio 12, and that's it. And that's exactly what they've chosen to do. So at the Canterbury University, we have a site license for Visual Studio 2010, so you can download and install that on your computer. Just find like a free full version of it. It's provided by the university's license with Microsoft. However, if we look at the release archive of Open Frameworks, we'll see, so the latest version is 0.8.3. So that only supports Visual Studio 2012, which the university doesn't have a site license for. So we can't use 0.8.3, 0.8.2, Visual Studio 2012, 8.1, 2012, 8.0, 2012, 0. This is before they changed the licensing thing, but 0074, Visual Studio 2010. So if you want to use the university's site license of Visual Studio, you have to go right back to Open Frameworks 0.0 or 0074, which is a bit of a pain. We tried to argue for it, but it's trying to get it past the uni is a bit of a pain. What we can do though is, if you go to the IDE setup guide for Visual Studio, you can actually use, so Microsoft provides Visual Studio 2012 Express, which is a free version, which I think works for like 6 months or something. I'm pretty sure it's got a limited time span anyway, because I tried to use it on my computer. Oh, can you? I'll re-enable it. Okay. Yeah, well, there you go. So you can download Visual Studio Express. It is sort of a lighter weight version, so it's missing some of the features, but certainly it's got all the features you need to write Open Frameworks apps. So you can download that just there, install it, run it fine. The other alternative is you can use DreamSpark. So DreamSpark is a Microsoft promotional thing to try and get students to use Microsoft tools, because students then go out and work in the workforce, and if they know how to use Visual Studio, then they can encourage companies to buy Visual Studio, and their products end up getting bought. So this is the DreamSpark website, so dreamspark.com. You go here, the site's a bit confusing, but if you go to down here, you see DreamSpark for students and download products, learn more there, and then you can go and sign in. Now, last time I checked this, which was earlier this year, Canterbury is included in the DreamSpark program. Don't quote me on that because I haven't tested it since then, but certainly as of the start of this year it was. But you can create an account, and as long as you create it with your university email address, you can have access to the DreamSpark software, which means you can get full versions of Visual Studio 2003, Windows 8 embedded, Visual Studio 2012, Visual Studio 2010 Connect for Windows SDK, as well as various versions of Windows Server. So if you are running Windows XP, you can download. Fortunately, they don't have 2000 of Windows 7 or Windows 8, but they do have the server versions of Windows, and you can do various training and certifications. So all of this is provided for free for students. So if you really want to use Visual Studio, you have the choice of using Visual Studio Express, or you can go to DreamSpark and download and install Visual Studio 2012 full version of DreamSpark, which is quite cool. But really you should be doing that on your personal PCs rather than university PCs, because it is personal for students, but yeah, it's up to you. But for this course, we're going to be using code blocks because it's free and we can get around all this stuff anyway. So the first thing we need to do, if we go into the Open Frameworks download page, we need to download code blocks. So that'll start downloading. I've already downloaded those, so I don't have to. And then if you go into the IDE setup guide, you'll see you need to download code blocks. And just to be difficult, we need to go downloads, download the binary release. And you'll see there's multiple versions you can get. So you can get code blocks with MinGW or another one. And we want the second one, so the one with MinGW. So we download that and blah, blah, blah. And hey, look, it's downloaded already. So yeah, we downloaded code blocks with MinGW. As it says here, like if we go back to the thing, it'll say with MinGW. Oh, and it started downloading anyway. And then we install it. So we install code blocks, and we want to make sure that MinGW is checked, because that's the compiler. So that will compile our code from text files that we can understand into machine code that the computer can understand. And then we install that, and that'll churn away in the background. And unfortunately, there is one other step we need to do to get it working. If you see down here, step E, we need to download a few files in order to make sure that it will work with Open Frameworks. So it's only a 4 meg file, and it's only a once-off thing you have to do. No, let's not run code blocks now. So let's just download this. And again, it's got all the instructions on the site, so follow through these, but code blocks, MinGW, include. Whoop. Damn run code blocks. So yeah, there's a little bit of messing around, unfortunately. It is actually a little bit easier to get it going with Visual Studio, but I wanted to give you guys the option of not using Visual Studio if you want. But basically, it's just you download a 5 meg zip file and unzip 2 folders, and then we should be good to go. So now we can run code blocks, and that's all set up, and we want to do that one, the GNU C++ compiler. And no, I'm going to leave everything as is. And this is code blocks, so we can start writing our code. So we can go File, New, and create a new project, class, whatever else. But let's grab Open Frameworks now. So I've downloaded it before, so we have to make sure we get the code blocks release. So you'll see here when we go to download Open Frameworks for code blocks or Visual Studio. So you download the zip, and then you just unzip it. Right, and now Open Frameworks is installed, so we are good to go. And yeah, that's the setup basically. So 5 minutes or thereabouts. So let's just what are we doing? Let's just go into this empty example. So we'll open this in code blocks so that we can step along with the example. Where is it? Frameworks, apps, my apps, empty example. Right, so we've got our empty example, which comes by default with Open Frameworks, open in code blocks now, ready to compile, and hopefully it will compile and run and not complain. Search file directory. All right, never mind, I'm not going to worry about that at this point in time. We'll deal with that later. But yeah, so as I said earlier, basically we have all these libraries which are provided by other people. We have all these libraries which are provided by Open Frameworks, and there's 3 files that we're ever really going to see. So main.cpp, test.h, and testapp.cpp. Okay, they're here. So main.cpp. Main.cpp is basically responsible for setting up Open Frameworks for us. So it creates a new OpenGL window. Here is the window size, 1024 by 768, and then it basically tells our app to start running. So that's all there is to it. Most of the time, unless you want to change the resolution or something of the window, or change the size of the window, you don't ever really need to worry about main.cpp, so we can just close that. So the next one is testapp.h. So testapp.h from last week, H files contain sort of it's a header file, so it contains the declaration or basically what our class looks like. So our class is called OFApp, Open Frameworks App, and it provides these functions: setup, update, and draw. And if you remember from processing, we had setup, update, and draw, setup, loop, and draw, or something. So pretty much the same thing. Setup runs when the program first gets executed. Update runs as fast as it can. Draw gets called every time the screen gets drawn. And then we also have a bunch of event-based stuff. So when a key is pressed, when a key is released, when a mouse moved, mouse dragged, mouse pressed, mouse released, window resized, drag event, got message. And oops. Then the last one is testapp.cpp. So if you want to modify, or if you want to add more functions or whatever to your OF app, you'd put them in ofapp.h, but this is where the bulk of our time is going to be spent, in ofapp.cpp. So you can see now here are all the definitions, so not the declarations, but the definitions of our functions. So ofapp.setup, that would be where we write our code that we want to run when the application first starts. OFApp update, draw, key pressed, key released, mouse move, etc., etc., etc. So that's where we're actually going to start. We're going to do the bulk of our work. That's where we're going to start filling stuff out at. So yeah, setup. You might load any assets you want to do. So load images, load textures, create objects. Initialize any values, initialize add-ons and components. So if any of the libraries need to be set up, that's where we do it. Update is where we do any calculations we want to run as fast as possible. So say you might be running a game with a physics engine, you might want to do all your physics calculations in update, so it's running all the time. Increment video frames, so if you're reading off of a video or whatever, you do that. And then in draw, we draw all our stuff to the screen. And we'll take a little bit of a break there for about 5 minutes, I guess, and then we'll come back and we'll start looking at actually writing code in Open Frameworks. Oh, no, it's still running. All right, so continue on. So yeah, we've got Open Frameworks up and running now, and we can do some stuff with it, hopefully. So let's have a look. I mentioned earlier that Open Frameworks has, actually this, something's missing out of here. Oh, that's all right. Yeah, so let's have a little look at how Open Frameworks is structured. So if we go into the base directory, we have add-ons. You can see here we've got a bunch of add-on things, and this is, in processing, we have that libraries directory, which is in the My Documents folder. This is pretty much the same thing. So these are all add-on libraries through stuff. So you can see we've got 3D model loaders, we've got GUI stuff, Connect stuff, networking, OpenCV, Open Sound Control, stuff for handling scalable vector graphics, and so on and so forth. And we've got apps, which is where our apps will go. Docs, which is empty, more or less. A bunch of examples, which is nice. Export, we don't need to worry about. Libs, which is all the libraries which come by default. Other, which for some reason has serial test in there. Scripts, which we don't need to worry about again. And Project Generator. So Project Generator basically allows us to create Open Frameworks projects really easily. So before I sort of showed you the process we'd have to go through in order to create a project using OpenCV. So you have to open up all these things. You have to know where stuff's installed to, so on and so forth. With Project Generator, we just double click on it and run it, and it runs this little program. So at the top, we can define what we want so they call them sketches here, like in processing. So what our program to be called, my sketch, where we want to put it. So usually we'll just put it under my apps because that's the best place to go. What platforms we're building for, so Windows code blocks, and this actually isn't changeable. This depends on which version of code blocks you download. And then any add-ons we want. So if we click on add-ons, you'll see here are some of the default ones. So the model loader, GUI, Connect, Network. So we can check things and turn them on and off. So yeah, let's just go back. And now when I hit Generate Project, if we go back into the apps, my apps, you see now, in addition to empty example, we've got my sketch. So this is my program that's been created for me, and we're ready to go. So let's just open this up in code blocks. Yes, I want to build it. Brilliant. Okay. Libs. It's compiled. Lib. CV. Interesting. So for some reason that didn't unzip, or is it just not built? Let's try that again. For some reason, some of the Open Frameworks lib files don't seem to be there, which is unusual because I literally just unzipped this on my own computer like an hour and a half ago, and they were there. But they're not. Huh. Okay. Might have to pause this for a minute, unfortunately. Unless I can figure out why it's not building. Actually, let's close project. Try that again. All right, bear with me 1 minute. I'm just going to go down to my computer and copy the Open Frameworks directory across because for some reason it hasn't copied onto this machine. I'll be 1 minute. Sorry about that. Hopefully that will work. And perhaps if I might put this version of Open Frameworks on my HitLab drop zone so that if you guys have problems with it as well, you can just grab a working one, a known working one, I guess. No. So that's going to take a little while, so I might as well just continue on. I'll come back to that. Right. So let's start with some graphic stuff because obviously that's the most important thing, or the first most important thing we want to look at. So in processing, we did stuff using the processing rendering toolkit, which was built on top of the Java rendering toolkit, or could also use OpenGL as well. Natively, Open Framework uses OpenGL as its graphics rendering engine and provides a whole bunch of simple functions which encapsulate various OpenGL functionality to make it easier to use. So, you know, we saw before when we looked at the Open Frameworks documentation, they had a bunch of stuff around both 3D and where's it going? Both 3D and OpenGL stuff. So various OpenGL utilities and things to draw all sorts of shapes and so on and so forth as well. So these are the sort of things you look at when you're doing an Open Frameworks. So things like OF background, OF set color, OF fill, no fill, circle, triangle, ellipse, and stuff will draw primitives. Begin shape and end shape, which we saw in processing as well. Vertex, curve vertex, or Bezier vertex. So there's a bit more flexibility there as to whether, you know, if you're drawing a shape, whether you just want a vertex or whether you want a vertex which will curve. Like if you're drawing a straight line, it'll curve through there, or do Bezier curves. Turning off on and off alpha blending. How far is this? 60%. Still got a minute left. So yeah. So 2D image functions, if we are doing turning on or off fill, like these will just be functions OF fill, OF no fill, exactly like we saw in processing. So they had their fill and no fill functions, or I can't remember the exact name, but it was something similar to that. Things like creating circles, so that'll be like probably X position, Y position, and radius. Setting colors, you can set it in hex if you want. So that'll be, the first two will be red, blue, or red, green, and then blue, or blue, green, and then red. You'd have to test it out, but 00 to FF from 00 to 255. Or, of course, we can do things the way we're used to and just use OF set color with the RGB and optionally alpha values. Right. Oops. So yeah, primitives, OF circle, XYZ, OF rect, top left, top right, width, height, lines, start point and end point in XY coordinates, drawing some text, so draw a bitmap string, you pass in what you want to write and where you want to, or what text you want to write and where you want it to appear on the screen, and so on and so forth. I do have an example of this, and hopefully this will work now. Well, I will be very frustrated. Code blocks. Yes, something's happening. So right, this is a little example demo I whipped up, which draws circles really, really quickly. There is actually an example which goes with it with processing, but I don't have that with me, unfortunately. But yeah, you can sort of see, depending on which implementation, which graphical rendering you're using in processing, you can sort of see these ones don't have aliasing or blending, whereas these ones do. So using OpenGL, you can actually get some nicer effects around aliasing and stuff. I think by default, the processing one has aliasing enabled anyway, so not a huge deal. But let's have a little look at where is everything. Let's have a little look at this draw circles example. So we've got circle grid. Our main function is exactly the same as every other main function, so I haven't actually changed anything in there at all. OFApp has one new function added, so draw circle grid. And then in here, we have in our OFApp, we've set the background to 0, 0, 0, so we turn it to black. And then in our draw method, we just call draw circle grid. And that's all that's there. So draw circle grid does an XY loop for grid height and grid width by grid steps. So these are just some variables that defined earlier. So the grid should be 800 pixels wide, 600 pixels high, and a step of 40 pixels. So each circle is going to be 40 pixels across. And then it just calculates a random value between 0 and 255 for the red color, and then sets it to that red color by 0 by 255. Then calculates the random radius from 10 to 40, so rand mod 30. So the rand function is the C rand function, which returns a number between 0 and rand max, so rand max. But if you want to to reduce that number down, you can use this function here, which is modulo. So it will basically means cap this number between 0 and 30, and then add 10 to that, so it'll go between 10 and 40. And then we just draw an ellipse, or we could draw a circle, but in this case it's an ellipse, at X and Y position. So X and Y is the position based on the grid, and then the radius is calculated randomly. And yeah, if we run this, we see it's just drawing a whole bunch of purple circles really quickly. And if I pause that, the circles it's kind of hard to see there, but they're fairly anti-aliased on here and generally look quite pleasant. So that's lovely. Yeah, so it's like processing. It's really simple to just start writing code in, and if we run no fill, doesn't actually do anything. Yeah. So circle grid, using this example, we set up the size of the window. So in processing, we do size 800 by 600 OpenGL. In processing, we have this OF set up OpenGL 800 by 600 OF window. So, you can pretty much see that these two functions are pretty much doing the same thing. We declare some variables. So in processing, we would put that at the top of the file. In Open Frameworks, we either put it at the top of of.cpp. Actually, I need to update these slides. So I did mention testapp.h and testapp.cpp. In the latest version of Open Frameworks, 0.8.3, they've changed it from testapp to OF. So that should actually be OF app like that now. Sorry, I only found that out this morning. I didn't have time to change the slides. But yeah, so in processing, you'd put the code at the top of the function. In Open Frameworks, you put it at the top, either the top of ofapp.cpp or in ofapp.h if you want. Background color processing, you just say background 0, but you need to call the function inside draw each time. And open frameworks 000, and you need to call it once. So in processing, we need to say every time we want to draw a new background. In open frameworks, it actually clears the image plane each time we draw it, which is, you know, potentially a good thing or a bad thing. So it was really easy to draw things with trails and processing because we just draw on the last window that we had. In open frameworks, it clears the window each time we run it. If we want to disable that, we have to use this code here, OF set background auto, and we can just pop that into our setup function like that. So OF set background auto false will disable the automatic, which should do, but it doesn't actually look like it has. Which, oh, hold on, I might need to rebuild that. So I've actually turned on and off two things there. So I turned off no fill before. Sorry, I didn't realize in Visual Studio, if you make a change to the file and then run it, it'll build it automatically. Apparently in code blocks, you need to specify that you want to build and then run it. So yeah, now you can see it's not clearing the background every time. So we're getting this sort of trippy hypnotic thing where it's just drawing the circles over the last circles which were there. So yeah, the default behavior between processing and open frameworks is a little bit different. In processing, we need to clear the background manually. In open frameworks, by default, it clears it automatically, but we can disable that if we want. And then drawing circles, processing, set ellipse. In open frameworks, we use OF circle or OF ellipse. So yeah, nice and easy. So as I mentioned before, open frameworks comes with a bunch of examples, which are in the examples folder. And so if, say, for example, we want to look at graphics examples, we go into examples graphics, and there's a ton here. So which one was that one? Graphics example, that one. So yeah, again, worth having a look over some of these because, go away. Worth having a look at some of these because, you know, they go into a lot more detail than the examples that we'll have time to go through in class go. So yeah, you've got things like, so this is one they provide, so you've got this undulating circle, a whole bunch of random rectangles, transparency, I'm pretty sure, yeah, so this one actually, the transparency changes, so if you look now, this one gets less and less transparent, I think this one gets more and more transparent as they go, and lines, and we can do anti-aliasing on the lines, so you can see here they're all jaggy, here they're slightly smoother, and so on and so forth. But yeah, I've got a bunch of other functions in here, like set the resolution of the circle. So, you know, here it's quite smooth because it's 50. If we change that down to well, that's not ideal, is it? Doesn't want to. Okay, it's fine, we can play that game. Recent projects. Yeah, so if we change the circle resolution way down, we should find that the circles are a little bit more jaggy than they were, or in this case, they're just a line, because we're only drawing it. So if you remember when we looked at the OpenGL examples, or like just rendering things in processing earlier, when we create a circle, we basically create it out of a bunch of lines. So the more lines we have, the smoother, the more circular it is, the smoother it looks. So if maybe I'll make that 8, because 1 only doesn't really give us much to work with. So if I set that to 8 instead, you now see it's hexagonal, and obviously the more things we add, the smoother it gets. So, you know, there's one function which allows us to set the resolution of them all in one go, and then, you know, you've got stuff here, how to draw the circle, the outline, drawing random rectangles, doing stuff, enable alpha blending, so if you want to do some blending, and then the last number is the alpha value, so The closer to 255 it is, the more opaque it is. The closer to 0 it is, the more transparent it is. And drawing lines and enable and disable anti-aliasing if we want things nice and smooth or we don't care so much. So drawing polygons, and this is fairly similar to what we saw, well, pretty much exactly the same actually as what we saw in processing. So we do OF begin shape and OF end shape, and then we define some vertices in the middle. So whoops, I actually have an example I put together myself. Open apps, my apps, drawing example, that one. So this is one I put together which sort of shows the various different types of stuff you can do. So set up background. So alpha blended red circle, so that looks orange, but it's actually red. It's just half alpha blended, so it's picked up the yellow off the background. We draw a circle. This is a blue rectangle, it looks kind of black, but it's blue. So okay, that's kind of useless. Maybe I need to just jump into the OF rect. All right. Okay. So yeah, width, height, and then Z value. If you want to put a Z value, X, Y, and if you want to put a Z positional value in there, you can, but you don't have to. And then width and height. Where are we? No, not that one. Sorry, I didn't want to close that one. Then we have this black line, which is just a line, and then if we just do OF begin shape and then some vertices, we can draw some shapes. So here I just drew an arrowhead, and from memory, I believe it works in pretty much the same way as processing, where that last value there, true or false, will close our shape. So if we have OF begin shape, the shape, and then true, it will close the shape, so it'll draw that last line in there. Otherwise, if we have it false, it'll just leave it as is. So yeah, that's a simple little example that, I'll put the code online for you guys if you want to have a look, to show drawing some various shapes. But obviously there's a whole bunch of other ones which come with open frameworks which do it as well. So here's another example. I just find that sometimes the examples provided with open frameworks and even processing are more complicated than they need to be. But that's right. It's still running. So that's quite annoying. Alright, so apparently that's one of the reasons why code blocks hasn't been completely adopted, because if you don't close your program down, it just sits there and does nothing. It's okay, you don't have to use code blocks if you don't want, you can use Visual Studio. That's alright, we can work with it, just means we have to close some stuff down sometimes. But yeah, the thing with open frameworks obviously is that if I write some code in code blocks to run on Visual Studio or whatever, it'll also run on code blocks that'll run on all the other ones. We just have to provide the test or the ofapp.h, ofapp.cpp, and main. But yeah, so here's their polygon example. So we have some winding rules. So we draw the same thing, but if we draw it diagonally with the winding rule odd, then it'll only draw the inside and leave that part. So this will be like 1, 2, 3, 4, 5, the vertices defined in that order, and it draws the hollow part. If we draw the same star but the winding rule non-zero, it'll draw the center. This one's dynamically created shape with the number of points increase and decrease depending on the mouse's Y position, and the radius increases and decreases depending on the vertical position. random points, sine and cos stuff. So I mentioned before there's curve and Bezier curve vertices. So these are curve vertex. So you can see here we have a vertex here, 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 here. And when it draws its objects, it tries to fit them to that curve. So it tries to make the object nice and shapely. So you can see, it sort of curves around here, and it'll do its best to pass, well, it'll pass through each of these points, but it'll follow a tangent. So you can draw nice curved shapes based on a rough diagram. Bezier curves are, have any of you guys ever worked with Bezier curves? It's kind of, they're curves as well, but the way you define them is a bit different. So you usually have two control points, and then that'll manipulate the weights of drawing it. So you can see the start point, the end point, and then there's two control points which define how the curve goes between the two end points. So these, these points here are obviously just floating around randomly, drawing contours, and then doing various like operations such as find the union of these two shapes, find the intersection of these two shapes. Right. Sorry. So images and videos. So that's, I'm not going to spend too long on that because it's pretty much exactly the same thing as processing. I just wanted to show how similar to processing it is. In fact, you could probably copy and paste most of your processing code and just add OF to the beginning of all the functions, and they should work fairly straightforward. Obviously, that's not going to be true for everything, but it's fairly close. So let's have a look at images and videos now. I really hope this one's going to work because I didn't test this one. All right, cool, so it did. So this is one I threw together a while ago, so this is just, excuse the music. Well, it's just to show that it can play music, but this is basically, loading the HIT Lab logo that I stole off the web page and a video we have on YouTube of the spider phobia demo that myself and a couple of students put together a while ago. But yeah, if you have a look at the source code for this, so any of you have done any sort of like work with like image and video processing in C, will know that doing stuff can be, like with images and video, can be kind of a pain. But here in Open Frameworks, we create OF image HitLab logo, so that's going to be our image, OF video player phobia video, and then, so that's in our OF app.h, and then in our OF app.setup, we call .load image to load our image, .load movie to load our movie, and then we tell our movie to start playing. The only gotcha or thing to watch out with is in the update method you have to call .update. If you don't call that, then it'll just stay on the same frame all the time. It won't play any of the audio or whatever. And then in our draw method, we define where we want to draw them. So 10 by 10 and then 10 by the logo height plus 20. So, we could very easily sort of do modulo. What's our width of this? 1024. And when you're closing down the OF windows, if you want code blocks to play nicely, you just hit escape and it'll close the window, and then you can just close the window in the background because otherwise code block seems to be packing sad. So yeah, now my video is playing at random and epilepsy inducing, but it's working, other than there's obviously a bit of screen tear there because it's happening so fast that it's happening faster than the window can actually render itself. Yeah, so really easy to do sort of images and videos. Actually, and there was one other thing I did in here. So you can see there's this mouse pressed function. Oh, okay, this isn't going to work because this window is moving around like crazy. So I basically had this mouse press function, so I check to see what the button is. So I think button 0 is left, button 1 is right, and button 2 is in the middle. And I basically said if the X position is, I know where this is, it's at 10 by 10 by 10 by video, whatever, phobia video. So I basically check to see if the X position's in here, and the Y position's in here, and if I click on that, we just pause the video. So I can click on it to pause and unpause the video. So if we want to set paused, or if we want to pause the video, we just call set paused, and is paused will return whether it's paused or not. So yeah, really easy to load videos, load and play videos and images and so on and so forth. So OF image has load image, draw, resize, save image, so you can actually modify your images and save them as well. OF video player has load movie, play, update, which I've bolded because it's an easy one to forget. Draw, set speed and set pause, so you can actually speed up and slow down. And in fact, there is one example I saw in here. Video player example, I think was this one. Yeah, so, you know, when I move the mouse back and forward, it changes the speed at which the video is played at. And then if I play it backwards, and yeah, then you can also, if I push, which one is the F to change, then you can actually step to various like frames one by one. So you can do, you know, you can write your own little video player in there if you so want. The OF video player like requires QuickTime though, so if you want to do video stuff, you probably need to bundle it with the QuickTime library, simply because that's what it's like. If you remember way back to, oops, the slide here, you know, OpenFrameworks provides these libraries, but they're built on top of these ones. So its OF video thing is built on top of QuickTime to do graphics libraries, video loading and saving. Sorry. And yeah, so OFX comes with a bunch of user interface stuff, but let's have a look at how we can use libraries. So we're going to use OFX UI, which is one of the libraries which come with it. So, you know, if we go into the OFX website and then go to downloads and add-ons, or just go to ofxaddons.com, there are thousands and thousands and thousands of these libraries you can use to do just about everything you could ever want to do. But one we will have a quick look at is OFX UI. So we click on the name of it. And then, so it's in GitHub. If you guys aren't familiar with GitHub, it's basically an online source code repository that people put their source code up and you can download it. If you want to get something off it, you just go to the page and then hit download zip. And hopefully that will download. It'd be nice if it told us how big it was, so I know how long I have to wait, but it shouldn't be much bigger than that. But yeah, so it was inspired and influenced by Control P5 and some other ones. So Control P5 is one of the ones we looked at for processing, so it's kind of convenient. But yeah, so let's, if we want to install an add-on, so we've just downloaded this add-on OFX UI. It's exactly the same, or it's just as easy as in processing. So we go to our Open Frameworks directory, go into add-ons, and then we just click and drag that into there. And now you see OFX UI. Now because this came off GitHub, it will have master appended to the name because it's the master repository. You can have various branches and various else, so we'll just get rid of that master at the end of it. And we should be good to go. So now if I run my project generator, like we're doing before, let's call it my UI sketch this time. Oops. And we go into add-ons. Now you see these are the ones which come by default, and here's OFX UI on the second pane of non-core add-ons that I've decided to add. And when I hit generate project, we are good to go. So now we can jump in here, and my UI sketch. Nope, this one. My UI sketch. So I can open this, and it will, my UI sketch will have OFX. You can see in the add-ons folder, it's got OFX UI included in it, so it's all ready to go. Start writing some things out. So I'm pretty sure OFX UI comes with some examples as well. Let's have a little look at one of their examples so you can see what sort of functions it provides. Okay. Never mind. So unfortunately it was built using Visual Studio, so we're not going to be able to just open the examples, but the good thing about how Open Frameworks and stuff works is basically, as I mentioned, all that code is included in those three files: main, test app and OF app. So we can just go into, let's just open my UI sketch here and grab the example we want to see, and let's just copy and paste those into there. So we'll just overwrite the ones we had. So my UI.sketch should now have all the code of that. And if we run this, so yeah, sorry, I should have mentioned OFX UI it's a UI library, but it actually provides some other functionality as well. It allows you to load and save the state of the window. So, you know, if you're oftentimes when you use programs, you drag toolbars around, you change how things want, and then when you close a program, it saves where all the things are. OFX UI supports that, and it does that using XML. So when you create your thing, you need to check OFX XML settings as well. Otherwise, it will just complain that it can't find it. So let's just create a new one with OFX XML settings as well. That's one which I screw up every time because I always forget about that. So we'll just need to copy and paste those into there again. Let's close that one because we don't need that anymore. So let's try it. This one this time, and hopefully we'll get a little bit further. Right. Yeah, no, we might as well wait because we're going. Any questions so far? Just while we wait for this to compile. So it always takes, like first time you compile a set of libraries, so for example OFX UI, it usually takes quite a while because it has to compile all the libraries. But after that, like if I did another thing using OFX UI after this, it should be quite quick. But yeah, any questions so far?
You use a different version of Visual Studio, so does it just not work with just break?
No, so it just won't work. Like so each of the libraries are compiled. So, you know, if you download OFX 0.083 or whatever it was, the libraries have been built for Visual Studio 2012. So if you try and run it in 2010, it just won't work.
Right.
You can download the source code and compile it yourself if you want, but that's probably more trouble than kind of defeats the purpose of using open frameworks, which is supposed to make things easier because it makes life a lot harder. But yeah, like as I said, you know, all the new versions use Visual Studio 2012, and you can either download the Express version for free, or you can download it off DreamSpark and get the full version. Or if you want to use Visual Studio 2010, just go back to an older version of open frameworks. It just means some of the add-ons may not work because often they're compiled against a certain thing. Now this is an error I came up against earlier, which in my experience seems to be linked to this version of open frameworks and possibly to this version of open frameworks for code blocks, which is a little bit annoying. But you can see it's complaining that it can't find this DLL. So all these DLLs are actually in the project generator file. So what you can do is actually just copy everything in the project generator file apart from maybe project generator.exe and just pop that into the bin folder. So we're trying to run my UI sketch too. Let's go into the bin folder, and if we copy and paste all that in there, it should work now. There we go. So yeah, it's all sort of running. You can do various bits and pieces with it, which is kind of cool. You can see here it's complaining drawing an unallocated texture. That's because this one actually comes with a texture which I didn't copy across. So if we go into OFX UI bin, so in the bin folder, there's a data folder, and that's where you put all your textures and GUI stuff. So you can see this one's got a bunch of buttons and stuff. So if I actually just copy that data folder over to my example as well, that one. And And now we try that, we should have our images and all the other stuff we want as well. So yeah, this is pretty much all the widgets which OFX UI provides. So, you know, like the examples we looked at in processing, there's a bunch of different things. So there's horizontal sliders. So in this case, they've done ones to change the color of the background. Vertical sliders, there's radio buttons. So radio buttons only allow you to select one thing, have them vertically or horizontally aligned. Buttons, which you click on and then they turn off. Toggles, which click on and click off. Range sliders, so I can change the minimum and maximum range. Text boxes, waveform displays, spectrum displays, moving graphs, images, frames per second label, so it's running at 70 frames per second. Dialers, so you click and hold and then drag up and down or change. Label buttons, matrices, like image buttons, so toggle button, click on, click off, and button. Items that you can drag around, drop down lists, bi-level sliders, minimal sliders, frames per second sliders, so again it's 69, 70. Image sampler, so I can move around and grab a certain color off there. Toggle buttons, rotary sliders, so if you want to do some DJ stuff. Circle sliders, so increase, and two-dimensional pads. So, you know, if you look at a lot of these, look like the sort of stuff you might have if you're doing like sound mixing. That's because a lot of applications in open frameworks have been used for doing sound mixing and stuff. So there's been quite a few different examples where people have put together apps to control soundboards or control various theatrical productions or concerts or whatever else. But yeah, so these are the sorts of things that OFX UI provides. And I think I've got a really simple example that I whipped up a while ago. Photoboard. So if you look at that one, it's quite complicated, but this is one I threw together myself, showing how you can use it. So we have, in here our OFX UI canvas. So in OFX UI, we start with a canvas, which we draw everything on. So our canvas is, you just think of it like a screen that you can draw on. We've got some OF images, another OFX UI canvas, some labels, and so on and so forth. And then let's just run this app, and hopefully this will work. OFX UI.h. Why is it complaining? Right, okay, I see. Let me just recreate that one. Project generator, turn on XML. So when I created that one, I didn't actually include the OFX UI libraries, so it doesn't know what it's looking for. So let's just go into apps, my apps, Photoboard 2, and Photoboard. And as I said, I'll make all these available to you guys so you can try them out, all these examples. I'll open. Right. So hopefully this one will work now because it's actually built or using the OFX UI library. So yeah, let's just, while that's building, we'll have a little look at what's going on. So we have those canvases, and there's various ways you can build it, but the general idea is you sort of space things around depending on their relationship to each other. So we have our OFX UI canvas, and we define how big it is, so 00, 1024, 1024, and then we add our various widgets. So we're going to add a label down of the current position. So you've got to imagine you've got sort of like a cursor, like in Word or whatever, and you position things relative to that cursor. So we add an object down, and so it's going to put an object there, and then it's going to put the cursor after that object. So we add a widget down, OFX UI label, and then below that we're going to add a picture of Mark. To the right of that we're going to add a picture of Gun. To the right of that we're going to add a picture of Christoph. Below them, we're going to add a picture of me. So, but that's basically like pushing enter, so it goes all the way back again. And then we're going to add a picture of Tom, which I guess you guys haven't met. He's the international director of the lab. And then we create our other canvas, which is basically the profile page. So this is back when I put this together, back when that digital photo board out by the front door, we just set that up. So I was just showing how easily you could recreate the digital photo board in Open Frameworks. So yeah, basically we have one which shows the main screen, another one which shows people's profiles, and then we, when we click on somebody's name, we click on someone's name, it takes us to the thing. So, we have the label up top, so HITLab NZ staff. Where are we? HITLab NZ staff, and then below that we have a picture of Mark. To the right of Mark, the picture of Gun. To the right of Gun, there's a picture of Christoph. Below them, there's a picture of me, and to the right of me, there's a picture of Tom. And when I click on that, it takes us back to, or takes us to a profile page, and then there's a back button as well. We can get back. So yeah, I mean, most of the code is basically just saying load this image and stick it in this position. So it's really easy to get things up and going. The only other thing is update profile. Just when I click on someone's name, it sets the name correctly, their job description, and the profile picture, and then some stuff for when the mouse is pressed. We check to see if we're on the main page, and if so, we check, did the person click on Mark? So this is hit is a common thing, which most OFX UI objects will have. So if you say is hit and then pass on the X and Y thing, it basically means is this point within the bounds of this image? So when the mouse is pressed, so X and Y when this is called, the mouse has been clicked, X and Y will be the position of the mouse. And so when we call is hit, we're basically saying, is this position within or inside this object? So is it inside this picture? So is it Mark's picture, Guns, whatever else? And then the only other thing is when we resize it, it will just resize accordingly. And yeah, if someone clicks on the back button, it'll go back. So pretty straightforward. Yeah, so using OFX UI, check the README documentation of examples. Will show you how to do all that sort of stuff. And it's the idea of a coded UI versus what you see is what you get. So, what you see is what you get. You usually put stuff around and then it'll look exactly like that. The problem is, how do you deal with things like resizing and stuff like that? So if somebody resizes a window, what you see is what you get often fails because you've said, okay, I want it to look like this when the window's this big, and somebody resizes it. Do you just sort of draw stuff off the side, or do you move it around? Whereas if you code the UI, you can sort of say, we'll add it to the right, and then if there's no room, it'll just put it below it or something. So everyone happy with that? Yep, cool. So just moving into some advanced graphics using OpenGL. So this is pretty similar, again, to what we looked at in processing, and it's going to cover a lot of the same ground, but just to reiterate it. So what is OpenGL? It's the Open Graphics Library, cross-platform, cross-language, multi-platform API for 2D and 3D graphics. So it's quite powerful. It supports hardware rendering on all major video cards, so it's really fast. You basically issue a bunch of commands, and they get pushed to the video card to do stuff. So there's actually probably a more recent version than this out now, but version 4.3 was released 2012, so it's fairly modern. There's OpenGL ES, which runs on mobile, and it's got some other libraries as well. So there's OpenGL was the base one, then there's GLU, which provides a bunch of utilities on top of that, and GLUT, which provides stuff like creating windows and mouse events and all sorts of stuff. So yeah, GLUT is the OpenGL utility toolkit, provides platform UI. So OpenGL is actually designed to be platform agnostic, so it doesn't provide any functionality to create windows, to handle input or anything like that, because those are all specific to the operating system. The way Windows creates a window is different to the way Mac OS creates a window, is different to the way Linux creates a window. So OpenGL basically scrapped all of those, and you have the GLUT library if you want to use it, which basically adds that functionality specific to each operating system. So you download the Windows version of GLUT or the Mac OS version of GLUT, whatever else. Well, actually, it's one version, but it figures out what operating system it's running on and handles it. So yeah, Glut is used internally by Open Frameworks to handle all its window creation, stuff like that. So it's actually being used. I think we looked at these briefly when we were talking about OpenGL on processing, but yeah, MHIT is a good place if you want to have a look at some tutorials for OpenGL. They go all the way from like setting up OpenGL window, which we don't need to do if we're using Glut, to polygons and so on and so forth. But yeah, in pure OpenGL, all objects can be described by a set of primitive types. So we use GL begin and GL end and GL vertex to create our objects. So unlike processing, where we have to, do I still have a version open? Where we have to use its vertex to create vertices and stuff like that. Because Open Frameworks is built on top of C, which is built on, and all of its libraries are built on top of the OpenGL libraries and so on and so forth, all that functionality is actually still there. So if I open up one of these examples I've done, GL primitives, let's close this one. So yeah, so this is one I whipped up a while ago, which shows various ways of drawing the same shape. And if we have a look at it, there's drawing a red arrow with begin shape, but we can actually draw, and let's just, we'll just work our way through these. So if we look at this, it's the same shape drawn 3 times across the top and then 4 times across the bottom. If we look at this, so the first way we draw is using Open Frameworks code. So OF no fill, set the color, OF begin shape, and then define some vertices. However, if you're more familiar with OpenGL or you're stealing code off the MHIT tutorials or whatever, you can actually just write the pure GL code in there. You don't need to include anything else. You don't need to do anything else. You can just, instead of using OF vertex, you can use GL vertex, and it'll work because it's built. You have OpenGL and then the Open Frameworks library and then your code. So you can either interface into that Open Frameworks layer, or you can go below that and go straight into the GL vertex, the OpenGL library. So there's regardless of which way you want to do it, which way you're more comfortable, if you're using Open Frameworks or using OpenGL, you can do them all with an Open Framework. So I actually see that as a slight advantage over processing. Processing sort of encapsulates all this functionality, but it also prevents you from using it. So if you want to use OpenGL in processing, you have to use the OpenGL renderer, and then you have to use the processing code to access the OpenGL functions. If you're in Open Frameworks, you can just start writing your OpenGL code, or if you get some OpenGL code from somewhere else, you just copy and paste it into your application and it will work. You don't need to try and convert it or anything because it is just OpenGL. The Open Frameworks just provides a slightly neater way of doing it if you want to, which is nice. And yeah, we've seen this before, so various primitives, so points, lines, line loops, triangle strips like this, triangle fans, quads and quad strips. So this is why I actually wrote these applications. So with Open Frameworks, you define their object by contours. So we say, if we want to draw this shape, we say, okay, draw a begin shape A, B, C, D, and it will draw that whole shape. In OpenGL, you have to break it down by triangles and draw it. So A, B, C, draw one triangle, A, C, D, draw one triangle. So there's a few different examples I'll provide which show this. We're just running out of time, so I won't go over them too much. But this is one which has that first triangle is just drawn with OF begin shape. The second one is drawn out of lines. So there's a line, there's a line, there's a line, there's a line. The third one is drawn using a line loop. So 1, 2, 3, 4. Then on the bottom ones, we have OF begin shape with fill set on. So that's a shape drawn with Open Frameworks with fill set on. The second one is drawn out of 2 triangles. So one triangle there, the other triangle there. And then this one's drawn with a triangle strip. And the last one's drawn with a triangle fan. So, same ways of doing exactly the different ways of doing the same thing. And just have a look at OF or GL transformations as well. Need to close this one, that one. So yeah, this is what we looked at earlier. It's just showing, you know, same thing applies here with open frameworks as it did with processing regarding the order of transformations. So if we just close and run these various things. So if I rotate and then start drawing using open frameworks at various points. So in this one, we rotate it and then we draw at that position. So we rotate and then we draw each vertex at that place. You can see this starts at 300 by 100, 350 by 200. Here we translate it out and then rotate it. And then each thing is drawn relative to the new origin. Run. So, you know, it's now drawing it, it's now rotating it from the point of the arrow rather than the sort of the base of it. And then the last one rotates it, does this thing we've seen before where we translate. If we want to rotate around a certain thing, we translate, so that's at the origin, rotate it, and then translate back. So you can see here 0, 50, 0, rotate, 0, negative 50, 0. So before, if we think this is our arrow, our first example was sort of rotating from the middle, our second example was rotating from the top, and in our third example, it translates it from the top up to the middle, and so then it rotates from the middle again, like that. So, you know, exactly the same stuff we saw in processing regarding rotating. And 3D graphics are exactly the same. So we just add an additional dimension. So I'll skip over the cube example and I'll go to the texture cube example. That one, because the cube just draws a cube. Whereas the texture cube at least shows how you can do textures. So on this one we have the transformation, but we have an OF texture object. Ooh. An OF texture object, which is the texture we render onto each side, and then we load a bunch of images. And then here you see we load our images, and then we bind each image to texture, and we have this OF enable normalized texture chords, which just means that everything comes out as 0, 0 by 1, 1, which is what we saw in processing as well. So this one is a cube with our faces rendered on it. So yeah, you know, again, really easy to do textured stuff. You just load in the images using this OF image, and then when you want to enable that texture, you just go whatever text you want to bind, or whatever text you want to use, .bind, and then just draw it and use the texture chords, which is as in processing 0, 0, 1, 0, 1, 1, 0, 1. So the top left, bottom and right corners. And yeah, that will do for today. So sorry it's been a bit of a rush, but if you have any questions, let me know. Otherwise, I'll put these slides up online, and yeah, I'll put a link on the Learn site as well to where I'll put like code blocks and open frameworks with these examples on my drop zone, so you guys can download them from there. And that way, I don't know why. Well, I had problems getting open frameworks to work on here to begin with, but yeah, that version certainly works, and that way you can try out all the examples and should be all good. And then on Wednesday, we'll look at doing some more advanced stuff in open frameworks. But yeah, again, like with processing, no, I've only got like a few hours or 4 hours a week, so we don't have time to go into too much detail, but have a look at the examples, open up the source code, see what they do, see if you can figure out how they work. And yeah, I guess your assignment must be due tomorrow night at midnight or 11:55 p.m. So good luck.